This video is by Mark Kingston from the ARA Institute of Canterbury in Christchurch, New Zealand. Okay, so another video on using the chord length formula. I've done a couple already, but it's just to really try and give some clarification. One or two people are still asking questions on the subject. So the formula is that the chord length equals the diameter times sine A over 2 divided by 2. So on the board here I've drawn two circles, one at 342 millimeters diameter and this one over here at 435 millimeters diameter. On this one I've actually already put two chord lines across the circle, remembering that a chord line is a line that simply goes across a circle. And what I'm going to do is I'm going to do an equation here to stick a chord length across the circle. This one here we're going to transpose the formula and work back to determine what the angles are, because I've actually put some homework questions in on how to do that. So this is really about laying out jobs, large things that need to be taken out of a circle, a pattern. It could be a cone or something taken out of a circle, and this is the easiest way to do it. You could use a protractor. I've shown you a protractor before, but if you've got a very large circle, you're working with a very large object, a protractor is generally quite short, and you've got to stick some lines out to the very outside edge. Could be slightly out. Mathematically is the best way to do it. So let's say that we just want to put an angle in here of 113 degrees. So what do? Remember that we had to divide 113 by 2 for a start. So the chord length is the diameter, 342 times. So we have to divide this by 2 for a start. So what do we got? We've got 56.5 degrees. So that goes in there as sine 56.5. And I will do that on the calculator. So 342 times the sine 56.5 equals, and we get a length there of 285. So we'll just pick a start point. I've got a rule here. Actually, I'm going to do it with a compass, sorry. Self-organised. 285. So 285.1. So that would go into that point there. Scribe a arc on the circle. And that's going to be our line across our circle. So we'll just do a line across the circle from there to there. And we'll run it back to the centre, just so I explain myself clearly. So this portion here is 113 degrees. Using a straight line length across there, what did I say? 285.1 millimetres. It's 1/8, but one will do. If you're doing sheet metal work, you only generally have to work to a millimetre anyway. We're not doing machining or something like that. Light fab guys will, bit different with their dimensions. They might even be 290 or something. So that's how you do it using the formula in the standard format. Now that we want to work back from our actual sizes. So using the formula again, what did we do? We took the step of determining the chord length by working through the formula in that method. 342 times sine 56.5 gave us 285 millimetres. In this case, I've got the chord length of 365. I've got my diameter here of 435. And if we looked at the formula, we're trying to determine what that actual sine number is going to be. So when we transpose the formula, what we do, this is multiplying on this side, so it becomes a dividing factor. So it's 365, that's 365 divided by 435, and that would equals, if I can rub this out because the ink is probably still a wee bit wet. So what I would do on the calculator at that point, I would take my 365 divided by 435, and then I have to push the shift button and the sign button, and that gives me, in this case, at this point, 57.04 degrees. Or it just gives me that number basically, well, it is degrees. And remember, we divided our number by 2 for a start. So in this case, we have to times this by 2. So what we end up with is 114.04 degrees. So this one here, if I take my line back to there and then down to there, this portion in here is 114.04 degrees. So what about this one here, 222? Well, exactly the same way. If we had 222 equals the diameter, 435 times sine, trying to determine that. So in order to get back to sine, we remove this on this side and divide that by 222 divided by 435 gets us to the sine point. So doing that on my calculator, 222 divided by 435 equals, and then I push shift sine because it's the inverse, and at that point I get 30.69 degrees, and from there I have to times it by 2 to get back to my original angle. So times 2 is going to give me what? 61.38 degrees. So if I draw this in here, this portion in here is, what did I say? 61.38 degrees. So I've shown you in a couple of videos on how to determine a chord length given this formula. And then I've given you some equations giving you the chord length, and you've got to work your way back to the to determine the angle. So hopefully that video will help. Seems as clear as mud to me, but see how you go with it, and if there's any questions, of course, ask. Thank you. Leave it there.